Hello, and welcome to the Energy Efficiency and Renewable Energy module of Sustainable Building Training Series. In this short video, you can expect to learn about why energy efficiency is so important, how to make buildings more energy efficient, and how to utilize renewable energy. Concepts related to high-performance buildings and their synergies with renewable energy sources will be introduced. Buildings play a significant role in global energy consumption, constituting a substantial percentage. In the United States, buildings alone account for approximately 29% of all total energy usage, containing both residential and commercial structures. The combined energy consumption for residential and commercial sectors in 2022 reached around 22 quadrillion British thermal units, BTUs, 29% of the country's overall energy consumption during that year. This energy incorporates various purposes such as heating, cooling, lighting, and powering appliances. The latest national survey conducted by the U.S. Energy Information Administration, EIA, revealed that space heating, cooling, and air conditioning accounted for roughly 51% of the total energy use in buildings. Other notable contributors to energy consumption in buildings include water, heating, lighting, and appliances. This extreme energy consumption contributes to global climate change, emphasizing the need to prioritize energy efficiency and renewable energy resources within the building sector. Therefore, reducing energy consumption in buildings stands as a crucial step towards achieving global climate targets. Energy efficiency plays a crucial role in reducing the impact of buildings on climate change, as it directly addresses the demand for energy and mitigates the reliance on fossil fuels. The combustion of fossil fuels as an energy source in buildings has a significant impact due to the release of greenhouse gases. Energy consumption within buildings has influential consequences, affecting not only the environment but also the expenses and comfort of those occupying the buildings. Ineffective building designs increase the demand for energy, leading to an increased reliance on fossil fuels and further intensifying greenhouse gas emissions. The design of both the building itself and its outer shell are key factors in determining the energy usage of a building. The range of interventions that can be implemented to minimize energy consumption and its environmental impacts include strategies that reduce energy demand, integrating passive systems, and enhancing energy efficiency. The potential for mitigating these environmental impacts lies within the holistic design of buildings, starting from the conceptual and early stages of the design process and continuing throughout the construction, while even extending to post-occupancy evaluation. Various methods can be employed to reduce energy consumption in buildings, such as enhancing insulation and air sealing, incorporating energy-efficient appliances, employing renewable energy sources, and adjusting building operations. Let's explore some of the most common strategies influencing a building's energy performance and enhancing its energy efficiency. In this section, we'll go through some energy-efficient building strategies in more detail. Building orientation. Optimizing building orientation is one of the most fundamental yet effective strategies for energy efficiency. Positioning a building to maximize sun exposure during the winter for passive heating and minimize exposure during the summer for cooling can significantly reduce its energy consumption. Natural daylight is effectively harnessed in properly oriented buildings, reducing the need for artificial lighting and heating. Passive solar design. Solar energy is captured, stored, and distributed via the building's design in the winter and rejected in the summer. Effective passive solar design relies heavily on sun shading devices, thermal mass, and strategic window placements to improve comfort and reduce energy consumption. Reducing the need for active systems. Air sealing. In the building envelope, gaps, cracks, and openings can lead to significant energy loss. Sealing these gaps, cracks, and openings prevents unwanted air infiltration and exfiltration, ensuring comfortable indoor environments and reducing energy demands. Insulation. Proper insulation acts as a barrier to heat flow, vital for keeping the building warm in the winter and cool in the summer. Enhancing insulation can significantly reduce heating and cooling energy demand loads and ensure optimal indoor comfort. Efficient HVAC design. Well-designed HVAC systems ensure consistent comfort while operating with maximum efficiency, tailored to the specific needs of the building. As buildings become more energy efficient, there is corresponding reduction in the size and capacity of required HVAC systems. This results in substantial cost savings in installation and operations. In addition to the mentioned strategies, ASHRAE's Advanced Energy Design Guides present other recommendations to improve the energy performance of buildings, including the use of natural light to reduce reliance on artificial lighting, choosing appliances and equipment with EPA's Energy Star label ensures energy efficiency and the use of eco-friendly refrigerants. For equipment that uses refrigerants, prioritize those with a low global warming potential. Using advanced building management systems to automate and optimize energy use across different building systems, such as lighting, plug loads, and water heating systems. Design guidance such as ASHRAE's Advanced Energy Design Guides can help ensure that the implementation of energy efficiency strategies deliver the desired outcomes. Energy modeling is a predictive tool for evaluating and optimizing proposed design strategies. This involves using computer-based tools to simulate a building's energy performance. It provides insights into the effectiveness of various efficiency strategies, allowing architects and engineers to make informed decisions, optimize designs, and incorporate the most effective energy-saving measures. Commissioning ensures that the building systems operate in accordance with the operational needs and design intentions, thereby increasing energy efficiency, improved occupant comfort, and reduce long-term costs. The systematic verification that is central to the commissioning process enables optimized performance and minimizes the risk of system failure. In summary, commissioning helps to ensure proper implementation of energy efficiency strategies, while energy modeling predicts and validates the impact of the implementation. The utilization of renewable energy holds significant potential in enhancing both energy security and the reduction of greenhouse gas emissions in the United States. Increased reliance on renewable energy sources can significantly decrease reliance on fossil fuels and reduce energy imports. Use of fossil fuels currently account for the country's largest source of carbon dioxide emissions. The combustion of fossil fuels as an energy source in buildings contributes significantly to the climate change by releasing greenhouse gases. Up until the mid-1800s, wood served as the predominant energy source for heating, cooking, and lighting in the United States. During the late 1800s, fossil fuels such as coal, petroleum, and natural gas took over as primary energy sources. In 2022, renewable energy production and utilization in the United States attained unprecedented levels. Approximately 21% of the nation's electricity generation was sourced from renewable energy, marking a significant milestone. According to the U.S. Energy Information Administration, renewable energy accounted for roughly 13% of the total energy consumption in the country during that same year. Among the sectors, the electric power industry contained approximately 61% of the overall renewable energy consumption, while the residential and commercial sectors accounted for a mere 10%. Prior to the 1990s, hydropower and wood were the most widely utilized renewable energy resources. There was a subsequent increase in the use of biofuels, geothermal energy, solar power, and wind energy. Recently, there has been a significant surge in the installation of wind and solar energy systems, resulting in a remarkable growth in their overall capacity. The following factors determine the suitability of the different renewable energy technologies for a given building. 1, the accessibility of renewable energy resources near the building site. 2, the space available for installing renewable energy technology. 3, the cost of purchasing energy from a provider for the building. 4, the existence of incentives that can help offset the installation expenses of the renewable energy system. 5, the local regulations that may impact the utilization of renewable energy systems.
In summary, in this module, we've discussed why energy efficiency is so important, and we've also identified strategies that can be used to make our buildings more energy efficient. We have also explored options for utilizing renewable energy. I'm going to leave you with some concluding remarks. Some energy efficiency and renewable energy advocates have different opinions over which of these two strategies should be implemented in buildings first. We can draw some insights from an analysis that was done by the American Council for an Energy Efficient Economy. They confirmed that because energy efficiency is generally less expensive per kilowatt hour, it can be used to effectively lower consumption in a way that extends the impact of using renewable energy further. Their data showed that energy efficiency simultaneously allows solar to serve a higher percentage of energy consumption while also allowing a smaller and less expensive solar system to be installed. We are therefore encouraging you to advance your projects of high-performance buildings through considering energy efficiency and renewable energy as an integrated solution. Good luck with it.